Hello, this is a PowerPoint presentation for Systems and Design about utilising the SS, ADM and UML techniques to create a comedy venue by William Blake. Starting with the initial mind map, after reading the case study for quite some time, I understood that the basic processes were categorised based upon the types of tasks. The initial mind map shows what I perceive as the vital parts of the case study, picking out the important information, which meant I could create a more visual reminder, which makes it a lot easier to understand, rather than repeatedly reading through the case study, which is clearly a main benefit of creating a simple mind map as a reference point for what you will eventually attempt. Moving on to the system diagram. Now, a system diagram, it has three main elements, which are the admin, the comedian and the customer. Now, these external entities are going to want to perform certain tasks through the system, such as booking tickets. For example, the comedian could request in, and then output would be a comedian booking, event audience could request in as well. Okay. I'll go through some of the pros and cons of the data flow diagrams with you now. So some of the pros will be collaborating users with the system, which makes it a lot easier to understand. So graphically designed, which is universal, which means no miscommunication can occur. Precisely represented by all the variations of system design and components. It's very similar logically to the information network that would be operating the system if the system was eventually implemented. So obviously some of the cons here are, well, one of the main weaknesses is the data flow diagram is very lengthy to make. There's no instant support available for any bugs in the system, and they would have to be completely redone. Suppose someone doesn't understand the concepts and are given the DFD, it could make it more confusing than it would be helpful. Moving on to the context diagram of the data flow diagrams. The context diagram is a level diagram which shows a system and external entities and displays the entire company as one system, which then in turn helps to build on to data flow level 1. Before I move on, you can clearly see some of the inputs and outputs shown here, and some of the inputs would be payment information, output for example would be available events. Moving on to the data flow diagram level 1, as you can see here, the system has all the processes lined up in the middle, and on the left there is the agency, comedian, admin, customer. On the right you have the data stores and the associations in between. Okay, so here's the data flow level diagrams at level 2. So these break down the processes even further, as you can see here quite clearly. This is a make comedians booking. This is the first process in the data flow level 1, so the agency, entity, request comedian process and the data store. I'll go through the examples for, quite quickly due to time restraints, but you can freeze on the images if you would like to look closer at them. Okay. So here's an example here. Customer provides feedback, updates the feedback, adds feedback to event information. Okay, which brings us on to the expressment of the requirements. Now, the system was much easier to understand after creating the data flow diagrams, as it showed us what processes are involved in our comedy venue. We are now aware of what our external entities are, such as customer admin and comedian, which are the human elements of the system. Now we have data stores to hold the information. External entities provide such as event information data. Overall, I have a much broadened idea of how this venue needs to operate, in the sense that the data flow is now understandable, so you can see which way information is being passed around. Onto the entity matrix. So what happens is, once the entities have been identified and are cross-referenced with the data stores from the original data flow diagram, that then serves as a sort of check to see that the data is being held, used and also not duplicated. So the entity matrix was used to cross-reference the entities with the functions that are identified from earlier in Essential. So as part of the check, the matrix is drawn, as you can see here, and each entity is listed along with all the functions. So entities should have a process that creates, deletes and then also uses the... Moving on to the ERD, here you can see we have our composition of entities, attributes, associations, primary keys and foreign keys, which I've identified with PK and FK. What I'll do is I'll zoom in quickly for you to get a closer look. Okay, so here you can clearly see there are many one-to-many relationships, and the event entity is receiving a lot of attention from all the other systems that are around it, or processes, sorry. Okay, so I'll just go down so you can see that. Got customer payment status, all going down. Okay, moving on. Okay, moving on to entity life history. So the order of the boxes indicates a sequence. Events must occur in the sequence. So down here you would have the selection. So the O in the box indicates alternatives or multiple options. Now up here you can see the asterisk in the iteration box. So the iteration is 0 as allowed. So this construct can indicate that a state may or may not occur. The constructs are grouped together into tree-like structures. So the single box at the top indicates the entity. An event is something that happens in the real world to cause a change of state of a database. So for example, the ELH maps out the events that can impact upon an entity in the sequence in which they would occur. However, whilst most events can be modelled in a way of a sequence, some will happen at random. For example, a customer could, change their order whilst the order is still being processed. This is my second entity life history diagram. As you can see, it's very much similar to the first one, Comedian Payment being the main entity there, going down through Comedian Booking, storing details, examples for that. Moving on to the interpretation of the entity relationship diagram and the entity life history. So the ERD has a top-down approach to make the system much easier to understand the processes that goes one after another. If we were to actually create the comedy venue system, then the ERD and the ELHS would be utilised to create the databases required for the system to function. The ERD breaks down every process and entity and creates tables to store this information, then relay it to other parts of the system. It also displays the relationships between processes such as one-to-many or many-to-many. Moving on to the object-orientated tasks. So first of all, we had to redraw our mind map to represent a user stories mind map. So as you can see here, its main section is for user stories, which branches off to, say the customer wants to check its availability for the reason of to check times of available events. So it's very much like a what, why, and how people will interact with the system and what they'll be needing and why. Which brings us to the actual user story. Now what I've done is created a nice simple easy table so that I can reference it when I'm creating further diagrams. So for example, as a comedian I would want to inquire about different comedians and events so that I can find the best times to have an act on, and I've got it all organised in comedian, customer and the admin task so that I can separate when I'm trying to reference. From the user stories, it means that we can create a use case diagram. Now as you can clearly see, I have split up the tasks into separate sections. So the comedian related requests are up here, event audience related requests in the middle, and tasks for the admin are on the right, are down here. So on the right you have the administrator or the receptionist, and they're responsible for all the tasks, so there's a line or association going to each task. The comedian only would want to do 2 things, the customer may want to do 1, 2, 3, 4, 5 things, so that is displayed here, and that is the use case diagram. From the use case diagram we'll expand upon that in order to create a domain model diagram. So as you can see here we have operations that each person or entity would like to provide or do, such as check age restrictions or event, create an event. Each attribute would be entered in. Everyone has to have an ID. So you can see the flow of the information here. Okay, including all the way down to customer and comedian payment and the agency. My interpretation of the domain model diagram is that the domain model categorises the relationship among all the entities within the scope of the problem domain and commonly identifies their attributes. So this assists in creating a universal diagram to show the difference between the business aspects and also the system designers can understand in order to connect various aspects of the business, such as the entities and processes. Now this diagram is scalable, so it has low maintenance and it is simple to update. The model is a good way to test the feasibility of these certain business objects. From the domain model diagram, we can then use some of our user stories to go on to creating a robustness diagram. Now, I've chosen for my first diagram for the robustness for Comedian age check on the restrictions. So what would happen is the Comedian would ring in to check the age restrictions, the admin checks the event info database for age restrictions on certain events, the admin responds with the answer to the client's request. So some of the boundary objects would be the Comedian provides name and contact information to the admin would search for a specific event and then produces the information, and then the admin would then respond with the information through the telephone. Here you can see that user story displayed in the robustness diagram. So the Comedian would ring in, the boundary would bring a telephone to the admin would then request the Comedian information, the age restrictions information, and then upon that would enter the information and retrieve the event data from the event database. So the actors, the boundary, and the connections and associations are all there, and end up with the age restriction. Okay. Moving on to the robustness user story for customer cancelling tickets. So the customer story would be that the customer rings in to cancel a booking that was made previously. Then the admin requests the information and the confirmation receipt ID. Then the admin would update the cancelled tickets into customer information database. Then the admin updates 3 slots into the event database. Then the admin requests cancellation information, which then provides the customer with those details. This is the diagram for that user story right there. So as you can see, the customer requests cancel booking, once again the boundary being the telephone. The admin would then request the information, which would then update the customer cancellation through the customer data and provide the cancellation confirmation. And then the other thing that the admin would need to do would be to update the event availability to event data in order to provide the available slots that have just been freed up by the customer. From the robustness diagrams, we can then create state transition diagrams. So these have to have a start and an end and display when there is a change in the system or a state change. So the start would be an age restrictions request from the Comedian, which would then request the information, enter into the database, check the Comedian information, and then it would produce the age restrictions, followed by retrieving the age restrictions, which would then provide the information back to the Comedian. And the next diagram is the cancelled bookings. Now this is a bit more complicated as there are a fork in the road essentially. So the start would be cancel the booking request. So we've got request customer info, which would then go down to the confirm info, update customer information, which would hit here, joining it with this, and then provide the cancel information. Also entering the customer info in as well to update the event information for available slots. This is an interpretation of the state transition diagrams. Now, the state model diagrams are essential to how to explain the process of a single object. The only problem is that they're not very good for modelling multiple objects. As state diagrams are mostly micromanaged versions of the process, you can define all the possible states of the system in one easy-to-use diagram. The main difference between object-oriented analysis and other forms of analysis is that by the object-oriented approach, we organise requirements around the objects. So these integrate both behaviours, e.g. the processes and the states or the data that needs to be modelled after the real-world things that inspire the system and that the system interacts with. Reflection on the value of using object-oriented techniques are that the main difference between object-oriented analysis and other forms is that by the object approach we organise requirements around objects which then integrate the processes and the data such as states after the things that actually happen in the real world that inspire the system and that the system interacts with. So the main tasks in object-oriented analysis techniques are to find the objects that you require, organise them, describe how they interact, define the behaviour, and then define the internal systems of the objects. So for example, data can be modelled by ERD diagrams and behaviours by structure charts. Okay, that is the end of my presentation. Thank you very much.